Institute in Inta Castelar. Thank you very much. Can you hear me? Yes. This is one of the last presentations of today, but not last but not least, we are going to talk about carbon sequestration. Carbon is an indicator of quality and health of soil. When there is degradation, there's lack of carbon. Apart from sequestering carbon in our soil, we need to bear in mind is that we cannot accumulate carbon when there is degradation of the soil. So we have to take steps when we see the first indication of salinity, soil degradation, water deficit. So today we are proud to introduce Gonzalo, who's an expert in dynamics and low carbon content in or carbon content in no-till. His Magister in Soil Science of the University of Buenos Aires, and he has a PhD in biology. He is also a CONICET researcher, and he's an adjunct professor or associate professor in the university. I want to apologize in the first place because you normally want to find answers in this kind of presentations, but I really will pose more questions and probably you will not feel very comfortable. I don't know if you will receive many answers, but probably I bring along a list of things I would like to speak about. What is soil carbon? Some people don't know what is soil carbon. What is carbon sequestration? What is sequestration? What is not sequestration? Is it more convenient to use carbon or to accumulate carbon? This is controversial. How is carbon distributed under no-till? What happens with the introduction of carbon in no-till? So the first question is, what is soil carbon? No one will answer, please. Nobody knows what soil carbon is. I will speak about a topic that nobody knows about, organic matter. Is it organic matter? When we speak about carbon, do we speak about organic matter? Yes or no? Part. Organic matter is 50% carbon. When we talk about soil carbon, do we speak about organic matter? Not all carbon in the soil is organic matter. There are many zones, many areas in the Pampas region, or I would say most of it, has carbonate. There is a lot of carbon in another form, which is not organic matter. These charts show we have the rolling pampas, semi-arid region, and southern pampa. How many carbon is there in the carbonates? In the rolling pampas, we have some carbonate, but we do have carbonate carbon in the soil of the nucleus, in the core area of La Pampa. There is a lot of organic matter, but we also have carbon from carbonates. In the semi-arid region, in the Pampas, there are less organic matter, but there is more carbon from carbonates, especially in the tuff. I say this because the methods used to determine carbon content for certification are not the methods used in the lab that only require an organic matter. They require numbers for total carbon with an eco, for example. And this also gives carbon from carbonate, and we have carbon from carbonates across the Pampas region. I say this for methodological reasons. So across the Pampas region, we will find organic matter. No, so if we say that carbon is the same as organic matter, no. Organic carbon is organic matter, and carbonate carbon is the mixture of those things. What does it mean to sequester carbon? What does carbon sequestration mean? Nobody dares answer. It means that it stays in the soil. So sequestering carbon means increasing the carbon content in the soil. It is considered as carbon sequestration. This means that when we add carbon to the soil or higher than that carbon that goes out, we are sequestering carbon. We'll see this if we are soil-centered when we analyze this. But it's not so. But what is interest in the global community is to see whether there is less carbon in the atmosphere. What the international community needs is to have less CO2 in the atmosphere. So we have to look from another point of view. And we want to know what happens with the carbon in the system. We have to consider not only what is happening in the soil, but what is also happening in the system. Because in order to increase soil organic matter, I emit more than when I accumulate in the soil. I'm not sequestering carbon, I'm increasing emission. When we talk about the latest carbon in the soil, it does not talk about sequestration, carbon sequestration, but rather about the accumulation of carbon in the soil. This means that they have been sequestered. And this is not new. There is a paper, a work that has been done some years ago that made an assessment of the carbon balance under no-till. They observed that no-till caused two things. It increased soil organic matter. So as we increase no-till practices, organic matter increase, but also the emissions of nitrous oxide increased. This shows the nitrous oxide under no-till and under conventional tillage. Under no-till, it's 5 times more than under conventional till, and it depends on the urea rates as well. So that's why rates are higher. What's the carbon balance under no-till? At the beginning, it's positive because we increase soil organic matter, but when this stabilizes, and we know that this is not constant, increase is not constant because it becomes stable, a sort of negative count of nitrous oxide emissions occur. So we need to look at the whole picture, not only soil carbon, but we also need to consider that we have to reduce total emissions. I wanted to clarify this around this idea of carbon sequestration. And there is another dilemma, another paper that said, is it convenient to accumulate carbon, or it is better to use it? What's the use we give to organic matter at the end of the day? And this is something that we have to ask ourselves. What do we need the organic matter for? And so here I try to ask, there is Our paper that was published some years ago, which presented this topic, is it better to accumulate or to use the carbon? Are we forgetting about why carbon is important? It is important. Aren't we forgetting that carbon plays a significant role when it breaks down and not when it is accumulated? We are talking about mineralization. This is a process that has to do with this. So the idea in this paper was about this, to reduce the extraction or the emissions of carbon from the soil. Imagine that carbon balances input and output of carbon. We have to stop the output or to stop the exhaustion or the emission. So let's increase extraction of carbon, but also let's increase the introduction of carbon. That's why we need to increase introduction or addition of carbon. Let's see what model tells us. This is the AMG model. This is the most used model to model what happens with organic matter with soil carbon. It considers the mass of crop residued with coefficient of carbonization. It will tell us what's the active carbon in the organic matter, and then with a specific multiplications tell me how much we're losing of carbon. I won't go deep into details, but there are many things that impact on this. There is a factor of mineralization that takes into account temperature management, clay content. So everything, all this impacts on mineralization. Let's see what happens with the mineralizations. What do these models say about no-till? Passing from a reduced tillage to a no-till system reduces mineralization because we switch from an organic matter content of 2.5%, 16 degrees centigrade in Santa Fe, 1,100 millimeters rainfall. If you change or to switch to another system, you will reduce mineralization. It is a good thing if we want to increase organic matter, but we are stopping mineralization in this way. The objective would be to increase more organic matter in order to increase the nutrient content or addition. I apologize for this busy slide, but what happens with unification? How far are the crops unified under each tilling or farming system? With cereals, you reduce unifications because if you incorporate stubble or residue in reduced tillage or no-till, I'm promoting unification. This is what models tell us, and this is supported with data. So no-till is a system that mineralizes less because it provides less nutrients. We know this empirically because when you look at old tests, when tillage tests started, we needed to add more fertilizers to no-till systems crops. But if we want to have more nutrients, we need to increase the organic matter content far more than in other systems, especially consider that residue modification is less. It needs more volume of contribution of inputs in order to generate more organic matter.
What is this? Creation of organic matter include the stubble, weed, or other elements to create organic matter.
Como decía, mucho se oxida en superficie,
As this oxidation on the surface, the roots, and we started working on this together with Gervasio Piñeiro, who was here a few minutes ago, we began to talk, he began to talk about roots, rhiza, and over 30% of the crops, the average between crops and grassland, about 30% of total biomass goes to the roots or rhizo deposits. What happens in non-till systems? We have Eugenia Ollero here, and another person who have done a long-term trial in compaction in the case of non-till system. We can see that this is not a trial, this is a different plot. I don't know if you can see this, but the tool, this root is a T, has a T shape, where the area was opened, where the furrow was opened by the planter, that's where the root went down. We trust the contribution of the roots to the crops. That maybe this is we are biased because we have 70% of loams, but this is not the case in the picture. But we shouldn't just rely on the contribution of the roots. We should have a look at the physical features of the soil. This is the test, the trial mentioned. Look at the roots of sunflower in the furrow where the equipment, along which the equipment moves, we can see this. So this is one of the challenges faced by the non-till system management effect, and I'm coming to the end of my presentation here. These three trials done in different parts of the world show the vertical distribution of carbon, how the organic matter content changes when we move to conventional farming to non-till systems. And we have already known this for some time. The green squares show 0.20 depth. The depth we measure in Argentina. Usually we go down 20 centimeters. With non-till, there is an increase in organic matter. It goes at 0.20, especially at the first 10 centimeters. You have already seen this information. We have been sharing this information for 20 years. Now, what happens below? What happens between at the depth of 20 to 60 centimeters? Here, there's a loss. Again, a loss. Again, a loss. So, the deeper we move, when we move deeper, we change the system, we have more residues at the top, so there's an increase in carbon content at the top. But what happens below? We should be careful here, but there are some tools, alternatives. Here we see a graph with the use of cover crops. If we use a cover crop, carbon goes deeper into the soil. How much deeper? Which are the losses and increases? Let's talk about the figures. When changing from an annual crop to a pasture, half a ton per hectare per year. If we use nutrients, it's 4 tons of carbon per hectare per year. We have fertilization until with 0.2 when we go to 30 centimeters. If we look at a depth of 60 centimeters, the result is it's balanced between input and losses, because we have been talking about 8 tons of carbon buildup in a year. That's impossible. Again, are we? Maybe we're not remembering any longer. Why is organic matter important? let's remember why carbon is important for us. This is information coming from the center of Santa Fe. Organic matter contributes 70% of the nitrogen required by a corn crop. Over 200 sites were considered, over 200 in the case of wheat. 70% of the nitrogen for these crops comes from organic matter. This is a ratio between organic matter and zinc availability. If there is over 2.5 of organic matter in the soil, zinc availability increases. In all other cases, it's below 5. This is the response to boron in soils with different levels of organic matter. In the case of sunflower, microelements, zinc, boron. So the response to boron improves when there is more organic matter. So that's why organic matter is important. I'd like to thank you. Well, I am part of a group, part of my team is here, and I'd like to invite you on September 18 and 19, the CREA Congress in Technopolis. Thank you very much. Hello. So we'll see a QR code on the screen. You may scan it to send your questions using WhatsApp, and we will receive them on this mobile. Anyway, if you have a question here and you are not able to send it using your mobile, you may get the microphone. But before that, we'll give the floor to Matías. He's an agronomist and he has a degree in agronomy from Universidad Nacional del Sur. He is currently an assistant professor teaching the subject of soil management and conservation at the same university where he graduated, and he's also a researcher, a CONICET researcher. And his dissertation dealt with these themes: quality and dynamics of organic matter in the soil as an indicator of the results in non-till systems. So he's an expert in our subject matter. Good afternoon. Thank you very much for being here today. I know this has been a long day, so I'll try to have a very interesting presentation so that we can all go home and have a good rest until tomorrow. I organized my presentation starting with, in order to share the global scenario of Argentina, to talk about the organic carbon stock in Argentina and why is this important and why are we stressing the importance of carbon sequestration and build-up. Well, because it's one of the strategies used to mitigate part of the greenhouse gases agriculture produces. And in our country, the soils have lost organic matter, organic carbon, so they have a high potential to take up carbon and increase the carbon content in the soil. Why? Because agriculture in the last 20 years has become increasingly simpler with the use of glyphosate-resistant soybean as a monoculture, simpler production systems. So all these create a lower contribution of carbon to the soil. So this is the carbon contribution in the different systems. Simplified agriculture with limited replenishment of nutrients, with monocultures or limited rotation. So we are contributing 2 or 3 tons of carbon per year. Whereas in the past, when we had simple mixed systems, the contribution was twice as high, between 2 and 4 tons of carbon per hectare per year. And pastures, or grasslands, of course, have made a very significant contribution too. But the point is that the biomass we contribute is different. There is a difference between aerial biomass and roots biomass. In average, between 5 and 10% of the carbon contribution that comes through aerial biomass, only 5 to 10% gets into the soil as organic content. The rest is lost as carbon dioxide. Whereas when we talk about roots, though there is a more limited contribution than in the case of the aerial part of the plants, there is a high efficiency of carbon in the roots transformation into organic carbon in the soil. So we have to consider that the system is a dynamical one, where we have inputs, aerial, residues, roots, biomass, organic elements, and we have losses related to breaking down, mineralization, erosion. When we don't have a proper management, there are higher losses. And we see this in the Pampas region. There are many similar papers that show a reduction of organic carbon in the soil ranging between 30 and 70%. But there is agreement that usually we have these values, and this carbon is lost because it breaks down. So the carbon goes into the atmosphere in the shape of carbon dioxide. So if we want to know how we are positioned in our plots, in our farms, there are some tools available. For example, the carbon monitoring protocol that has been developed by experts from several associations in Argentina, Aapresid and CREA among them, and they tell us how to take a proper soil sampling so that the results we get when we analyze carbon content are reliable, and so that the results may be compared with other areas, other plots. So we have these maps. We have here we see the carbon contribution or the production of dry matter. We need to have to maintain the values of organic matter in the soil and the current organic carbon content in the soil. In 2023, INTA, with some organizations, they published this map showing organic carbon content in the soil up to 30 centimeters, and we have the lower, higher, and mean values throughout Argentina. So here we have information about what happens even before we take a sample, but we need to monitor to know the current status. So how do we carry out the monitoring? So if this soil has 2% of organic matter, is it good? Is it low? Is it high? Do I have enough organic carbon or not? So in those cases, we may compare the values we get with the reference values, or the values we get in a natural soil, that is, in a plot where no carbon has been taken out, in soils where the carbon contributions have been significant. Grasslands, parks, provided the texture is the same one. The texture in the two plots we are comparing. So this would give us an information about the carbon gaps or shortcomings on the surface and at at 20 centimeters depth. And that carbon value, which we calculate in the labs, very often we cannot use it as a threshold value, or there are no threshold values for organic matter. It's always better to have more organic matter, that's true, but for example, in mild weather conditions area, we may talk about 2%, 20 kilograms of organic carbon in the soil. So we compare this to those cases where the soils that have less carbon may have problems with compaction, degradation, physical problems, flooding, and we have seen this in soils of the wavy Pampa region, where 20 grams per kilogram is what we had when the values of apparent density were higher. That is, in those cases where there was, in those areas where there was more compaction. Do we have a problem here? Yes. Do we want to increase carbon accumulation? Yes. Or build up? Yes. So how does the system operate, so to say? We know that the soil, the potential capability of the soils to accumulate carbon will depend on the soil's property, texture, structure, mineralogy of the clay, drainage, whether it's a high area, a slope, a low area, and this will enable us to calculate the potential capability of storing carbon in the soil. Of course, this is all related to weather conditions, amount of rainfall, distribution of rainfall, temperature conditions, thermal changes affecting the soil, and all this will define the level of carbon accumulation that may be achieved in that soil.
As experts, as agronomists, we can't do much about this, but it is important to have some intervention here. Well, the agronomic practices that we can implement to improve the organic carbon content in the soil, to improve the, if I combine management and carbon management and soil management, I will have the elements that I need to have. What are the practices that I need to implement? This was published a couple of years ago. Different tests were assessed in the country. Different no-till systems were compared, combined or not, with these practices: fertilization, cover crops on rotation with perennial pasture. And what observations came out from these tests? The less effective practice was fertilization to improve carbon by 30 centimeters. The average was 180 kilos of carbon accumulated per year with balanced fertilization, nitrogen, phosphorus, sulfur. It also talked about base nutrients, basic nutrients. Second, we have the cover crops: oats, wheat, triticale, raygrass, clover, rape, vetch, legumes, radish. And using these crop services and no-till systems meant an increase of organic carbon in the first 30 centimeters of 4.8%, and this represented about 450 kilos per hectare per year, similar to what Gonzalo said about the half a ton that can be accumulated with cover crops. And pastures, different species, alfalfa, fescue, panicum, at different proportions, 50 and 50 different pastures, and there we saw the increase of almost 800 kilos of carbon per hectare per year. This for the country. Here we have the different tests that were conducted and that were assessed in this study, and it includes the whole Pampas region and part of the northern part as well. In the case of cover crops or service crops, in the typical arguidial soils in Cañada de Gómez, Santa Fe, about 65% of loam in the structure and the texture, and with also the carbon gaps that we have in the first 70 centimeters or 60 centimeters, we have a carbon gap of 60 tons less of carbon. In this case, we had soybean monoculture. In this situation, service crops were started to be used between 2006 and 2011, and these were the results. On the one hand, look at the top chart, we see carbon contribution of each crop, the soybean and soybean residue, and also the contribution of service crops that were wheat, oats, oat plus veg, and veg alone. We were able to tell what was the mass difference, and knowing what the contribution was, we were able to know that for this soil, typical arguidal for Cañada de Gómez, about 4,200 kilos of carbon contributed by the residue was needed to keep a stable level. But there were situations also where we were able to not maintain, but also contribute and replay or replenish the carbon that has been lost. And service crops contributing 600 kilos of carbon per hectare for a year. And monoculture of soybean, although it is planted under no-till system, there is a loss of carbon, and that is as much as 824 kilos per hectare per year. This is what happens with service crops, and we also saw this when we assessed organic carbon in the first 20 centimeters. We were able to see how in the check, as we made progress in the test, the levels went down, whereas with service crops, it was the reverse process. It increased as we had less contribution for the service crops. It is important, the contribution of carbon by service crops from the roots is also important. This will be retained as soil organic carbon, and this has been assessed in soils in southeast Buenos Aires with different service crops. We are also working together with the Bahía Blanca regional group from Aapresid. We are considering what is the biomass contribution from the roots of the service crops. And then we consider carbon contribution both for the biomass and the underground area. We also increase the element of grazing. And so this, to get a revenue or something, to get an economic revenue from that crop, we saw that have 50% more carbon with the residue than with grazing animals. No-till without fertilization, organic matter content went down, and we have 15 tons gaps, whereas no-till is combined with wheat monoculture when we applied fertilization. When we add fertilizer, those organic matter or organic carbon figures increased. I'm not showing this here, but we also have conventional tillage systems, and we saw that no-till without fertilization had a counter effect. It had a more negative effect than conventional tillage. No-till plus fertilization. This is the Biostas project, a very important very important project that started in 2009. I participated in this project. Good agricultural practices were assessed here. That it included diversified crop rotation, balanced fertilization, integrated pest management. Compared to situations where there was not a specific rotation, that carbon was not replenished. So we were able to observe that there was a higher frequency of soybean or more soybean planted in those areas. As we increased soybean frequency in our treatment, there was a significant drop in carbon contribution. And although in these systems, didn't show the real total carbon content produced by the different agricultural management, we saw another variables as particulate organic carbon, soluble carbon, macro or micro porosity. This is associated with compactions. So these show early indications, earlier than the plain organic carbon content. And we saw that when there was a low or a poor nutrients replenishment, we saw that we have higher bulk density values. So in this case, the organic carbon figures change. To summarize, no-till is not enough. It is a necessary condition, but not enough to try to accumulate carbon or recarbonize soil. Management will define the destination, where we want carbon in the soil or in the air. In some productive systems in our country, we see that there is a great variability of contributions in the air, above ground mass, and also in the soil. We do have potential to produce carbon, to add carbon, because these soils have lost carbon, so we have to replenish, we have to recover the carbon. Labile fractions often have a faster response than total organic carbon to assess different management practices and monitoring. We need to monitoring always in order to know how things are.
Mire, no sé si alguno de ustedes ya.
Finally, I don't know if you have already watched this. The old methods are still valid. They do work, Juan. I don't know if you have already watched the series. We know, and the same happens with the soil. We know what will help us to increase carbon content in the soil, balanced fertilization, cover crops, using their different biomass, aerial and urban, sustainable intensification, pastures in the systems where pastures may be used, pastures play a key role. There is no mystery here. We have evidence. There are some papers that deal with this and that support what I am saying, but isolated practices will not help us. In order to achieve a change in the organic carbon content in the soil, we need to use more than one tool so that the carbon balance is positive, so that the input is higher than the output. It's important to increase the input. We may talk about the output later on, but we have to increase the carbon contribution, the carbon content in the floor. It takes time. Carbon increases after 6 or 7 years. So if for 2 or 3 years we do something and we haven't achieved any results, well, we shouldn't get discouraged. We should keep on going, just like in Litoral, and we don't have to invent new things. It's necessary to invent new things, but it's also very important to do properly what we already know works well. Well, thank you. Let's take some questions which I have received over WhatsApp. This is a question for both speakers. It goes like this. Do you believe that the calculation of the total and particulate carbon stock is enough to compare the two agricultural systems, the non-till, and conventional systems, no-till? And should we use another kind of carbon to compare the systems? And which do you think would enable us to add more carbon? Very often, in order to assess a system, it's enough to have a look at the yields. The yields. When there's an increase in yield, we already know I have more organic matter and there are more nutrients going into the soil. This is clear evidence, and we don't need to do any analysis or tests to look at the kind of organic matter. It's important. The more labile fractions, there will be a faster response. In a short time, I will be able to improve those values if I use good management practices. And there are many kinds of indicators. We shouldn't get mixed up. I believe that if we know, or at least we should start by knowing about the carbon stock in the soil and knowing the baseline situation without any interventions, this will help us, well, again, to know the baseline. And when the production systems or productive systems are top productive systems, whether it's good crop protection, service, or cover crops, there we could start analyzing other indicators for carbon and fertility. I wanted to wait for your answer because I didn't want to contradict you. I work a lot in fractioning, but I agree that total carbon stock is still what we have to look up. Total organic matter, total carbon. I believe those are the best indicators. There are many others. Carbon in the microbial biomass, fractions that have lower density, particulates. There are many indicators, biological ones, but it's a very fine line, so sometimes with so much variability that the total carbon is still the most trustworthy figure. So we should only be careful here because we should measure at the same mass in the soil at any time. Bulk density changes depending on the management, and we cannot compare soils that have a different bulk density. If I measure in a soil that where there's a higher compaction, I'm actually measuring when I use the tool, if the soil is at this, it gets compaction, and if I measure again at the same depth, I'm measuring deeper actually. I'm measuring at the depth where we have less carbon because of the vertical distribution of carbon. So you have to look at the soil mass for proper comparison purposes. Should we measure at the same time every year? What role does the weather play? The best thing is to take samples always at the same time in the year with the same level of residues, though these elements are sometimes disregarded in the labs. But the most important thing is the number of samples. We should take all the samples that are necessary to detect changes. It's very difficult to identify changes in the short term because carbon has a high natural variability. In order for the normal build-up rates, you need 20 years to detect a change in the carbon stock in the soil with the natural variability and taking 3 samples per plot. Otherwise, we should increase the number of samples. So, as these are all farmers, we need to do soil analysis because very few farmers send samples of their soil to the labs. What is the relationship between the reduction of greenhouse gases in non-till with the increase in the emission of nitrous oxide? When we talk about global warming, what is the relationship between, well, lower carbon emissions with a 5-fold increase in nitrous oxide increase? This is one of the issues related to non-till. Each kilogram of nitrogen that goes into the atmosphere amounts to 300 times of the same amount of CO2. Even if there is a very low level of nitrous emissions, well, it has a huge impact on carbon balance in the long run. So if you do no-till and you don't have crop rotation, it's not no-till. The emissions vary a lot depending on the way urea is applied. So we have measured in the lab several technologies that reduce emissions significantly. For Mr. Berhongaray, for the semi-arid area, the west of Buenos Aires, east of La Pampa province, which would be a balanced combination of cover crops in order to balance the carbon contribution and the cycling of that organic content. Organic carbon content, PD, in agricultural rotation in summer crops. My question is, why shouldn't we use cash crops? This is an area where the rainfall, the area we're talking about is an area where the rainfall and the water tables, where we are talking about sandy areas, sandy soil. So that's the right place for double crops most years. Matías talked about this. Wheat has a huge impact, and we should dare to use to plant winter legumes in order to build up organic matter. The quantity is important. We have always talked about the quality of the residues. Yes. And the data tells us the amount or the quantity of residues is more important than the quality. So corn that produces more stubble makes a better contribution than another crop that doesn't produce so much residues. But I believe that that area, I would dare to think about double crops continuously if you cannot plant Wheat, we could plant a winter crop. We were talking about that. Earlier. I foster the planting of cash crops because today we need more winter crops. You can see that in many plots in the Pampas region, nothing has been planted. So even if although we know that cover crops don't produce any income, but cash crops do. So what we have learned throughout the years, we should leave the soil covered at all times. We should plow in a certain direction, reduce erosion, degradation. So we should apply what we have already learned. We have no more questions from the audience. And maybe for the last question, Gonzalo, you mentioned that the question was asked by a farmer. Maybe they could use winter cash crops, maybe not cover crops, but cover crops are necessary for that reason, because we have very limited crop rotation. If we have summer crops, we have corn, soybean, maybe sunflower. So maybe not every year, but sometimes barley or wheat should be included, or Visia that may add nitrogen. In the case of Visia, be careful because it breaks down quickly, the biomass goes away very quickly. Maybe it should be planted today together with the grass. I believe that in the east of La Pampa, rice goes very well. Well, not much more. I don't know if it's because of monetary reasons, but I would use an additional crop unless it has an impact on the yield of wheat or soybean. I believe that every 2 or 3 years a special crop should be planted because the carbon contribution of wheat was done at the flowering period. If we wait until it's harvest time, the contribution would be the carbon contribution of wheat would even be higher. We are told that you have no more time, so game over. Let's give them a round of applause. They represent us all over the world, and thank you for staying until the